So for this problem, they give us information about the current in the circuit, which is 18 amps, and the EMF of the battery, which is 9 volts. Part A is asking us to find the internal resistance of the battery, which we know that the resistance combines with conductivity and geometry. So in this case, we can represent the current flowing through the circuit as I equals E over R plus R sub internal, where R is the resistance of the resistor and the internal resistance equals the lowercase r. The short circuit here is basically equal to 0, so that means we can eliminate it from the equation and just use R internal equals E over I. And we can just plug in the information that they gave us and we come out with 0.5 ohms as the results. So the general equation kind of just allows us to learn more about the battery and the resistivities. Like, I guess in a way, the formula reminds us that the battery is not like pure voltage. It's not a pure voltage source compared to electromotive force, but it's a mixture of like resistance and pure voltage. So for part B, they're asked to find the power generated by the battery, which in this case we can use the formula power equals the current times the potential difference across the battery, which equals 162 joules over second. We're able to calculate the value when a small amount is when a small amount of change is from the location to another amount of the electric potential energy, and the energy change is equal to the charge times the potential difference, because electric potential energy per unit charge. So then it asks us to find how much energy is dissipated into the internal resistance every second. So we understand that the resistance of a resistor equals 10 ohms, and the internal resistance of the battery is 0.5 ohms. So the current flows through the 10 ohm resistor, giving us 0.86A. And then for part E, the power dissipates in the ohms resistor, coming out to equal 7.4 watts. So next, we're asked to find the potential difference across the 10 ohm resistor as 8.6 volts, and this equation is pretty important when it comes to the resistors, even though it's not a fundamental principle. However, it is an expression of the fact that some materials are ohmic but not batteries. So for that section, it came out to be 8.6 volts.